All right, in these next couple problems, we're going to connect some of the previous material on exponential functions to the more recent stuff we've been doing with logarithms. So question 5 is actually a throwback to something we saw in 13.1. It says, identify the growth or decline factor in each exponential function. Okay, so for part A, we have the function p of t is equal to 80 times this quantity 1 plus 0.075 raised to the t power. And let's suppose t here is, say, number of years, some reference point. And so let's say t is 0. Okay, then I'm going to get this number raised to the 0 power. That's going to equal 1. And 1 times 80 is 80. So in other words, 80 here is our initial value. Now when t is 1, I'm going to multiply this 80 by this number here, which is 1.075. If I set t to 2, this is going to be a square. So in other words, I'm just multiplying the initial value of 80 by 1.075 twice, and so on and so forth. Okay, so year to year, I'm just repeatedly multiplying by this number 1.075. So what percentage change am I applying year to year if this is my multiplier? Well, writing this multiplier in this form, 1 plus something, is really nice, okay, because the 1 is emphasizing that I'm taking 100% of the previous year's value, and then I'm tacking on this number, which as a percent is 7.5% of that previous year's value. Okay, so in total, I'm going to be increasing the previous year's value by 7.5% if I multiply by 1.075. So we call this the growth factor. So our growth factor for this function is 7.5%. Cool. All right. And then for part B, we have that y of x is 45 times 0.68 raised to the x. And so here, since this multiplier is less than 1, you want to think, okay, 100% minus, in this case, it'd be 32%, right? 0.68 is 68%. So year to year, I'm taking 68% of the previous year's value to get the present value, right? So in other words, I'm peeling off 32% each year. So 32% of that previous value, take that off to get the present value. So we call this the decline factor. Okay, so that'd be minus 32%. We apply a 32% decrease year to year. Okay. 6, a car that initially cost $25,000 increases in value by 14% every year. Write and solve an exponential equation to determine how long it'll take for the car to double in value. All right, so much like what we were doing up here, okay, if I'm thinking this is time and this is, say, value of the car, well, right at the beginning when t is 0, the value is 25,000. And now, from year to year, we're told that we have a value that increases by 14%. Okay, so each year, what are we going to multiply by? Well, I want to take 114% of the previous year's value to get the present value. So in other words, I'm going to be multiplying by 1.14 year to year. So this tells us then that our function for the value of the car after t years would be 25,000 times 1.14 raised to the t power. Okay, so now how long is it going to take for the car's initial value, for the car's value to double the initial value? So what is double the initial value? That would be $50,000 because our initial value is 25,000. So here's what I'm going to do. I'm just going to set the value v here to $50,000, and then I'm going to solve the resulting equation. So we have that 25,000 times 1.14 raised to the t power. This is going to equal 50,000. Now let's go ahead and divide both sides by 25,000. And on the left, that's just going to leave us with 1.14 to the t power. And 50,000 over 25,000, that's just 2, right? We've doubled the value. Okay, so now this is an exponential equation, so let's rewrite it so it's in logarithmic form. So t, the exponent, is the logarithm, and this will be a log base 1.14 of this number 2. Now I can go ahead and use that change of base formula to get an approximation to this value using our calculator. I'm going to take the log of 2 divided by the log of 1.14. So let's go ahead and do that here. So log 2 divided by the log of 1.14, that's about 5.29. So it's going to take about 5.29 years for the car's value to double from this initial value of 25,000. Cool. All right, 7. A home is purchased for P dollars and decreases in this case in value by 5% every month. How long will it take for the home's value to decrease to half of its purchase price? All right, so now we're looking at, say, T here is the number of years, and then I'll just call this the value of the home. And the thing we're not given, at least as a numerical value, is this initial price, right? The purchase price. So I'm going to call that just P dollars. Okay. Now from year to year, what's our multiplier going to be? Well, we decrease in value by 5%. So we're in this kind of scenario with a decline factor here of minus 5%. So I'm thinking, okay, I take 100% and then I take off 5%. So in other words, I'm going to be multiplying year to year by 0.95. So to build my value function here, v of t would equal the initial price, which is p, times this multiplier of 0.95 raised to the t power. Okay, and what do we want? It says, how long will it take for the home's value to decrease to half of its purchase price? So half of its purchase price will just be p divided by 2. Okay, so here's what we're going to do. We're just going to set our value, v, equal to p over 2. And then we're going to set that equal to this expression here, p times our 0.95 raised to the t power, and now solve this equation for t. And notice here that there's a p on both sides. So if I divide both sides by p from the very beginning, p is actually just going to cancel out. This will divide there, and this will divide there. So what we're really looking at here is just 1/2 on the left, and on the right we have 0.95 to the t. So our answer here is actually totally independent of the purchase price. Okay, so whether the person purchased the home for, $750,000 or maybe something like $200,000, okay, the amount of time it's going to take for that home's value to decrease to half of its purchase price will be the same. Okay, so now let's go ahead and solve. So this is an exponential equation. So as a logarithmic equation, the exponent t will equal the logarithm. The base there is 0.95, and we're taking the logarithm of a half. And I'll go ahead and write that in parentheses there just for emphasis. And now let's go ahead and again use the change of base formula. So the log of a half divided by the log of the base there, 0.95. And then we can go ahead and use our calculator again. So we got the log of a half divided by the log of 0.95, and we're seeing it's going to take just over 13.5 years for the home's value to decrease to half of its purchase price. All right, that's going to do it. Thanks so much.